welcome back to another video. Today we're looking at question 3, longest substring without repeating characters. The way we'll be approaching this problem is by using a hash set to store all of the unique characters that we've seen in the substring and using the size of the hash set to count the number of unique characters. In addition to that, we'll also be using two pointers, the left pointer and the right pointer. You can think of these pointers as something that we'll use to slide through the windows. And what this means is that we look at a particular substring. If it makes sense for us, we update the max value. If not, we keep moving that window so that we can look for new substrings without repeating characters. So let's look at an example. So we have the first example. So ABC, ABC, BB. So we'll start off with the set that's empty. The maximum value is 0 so far. These are the initial settings. Left is 0, right is 0. So we'll look at the character at the right index, which is A. A doesn't exist in the set, so you'd add that to the set, increment the value of max, and the right value will also be incremented. You look at B. B doesn't exist in the set, you'll add that to the set, and you'll increase the value of max, and then the right is incremented to 2. You'll do the same for C. C is added to the set, and then max is updated to 3. Left is still at 0, and then we increment right to 3, right? As soon as we come to third index, we see that A exists, right? We see that A exists in the subset, in the hash set. So what we do is we actually remove that. We remove the leftmost index character from the set. So we will remove A and we'll increment the value of left to be 1. And now the loop continues. It looks at the third index, which is A. So A doesn't exist. You will add A back into your subset, and your max is still 3. So it doesn't really make a difference. But you'll increment the value of right to be 4. And then you will come to the fourth index. You see B, and then B is removed. And the reason why B is removed is because we look at the leftmost index, which is 1, and 1 here represents B. So you'll remove B. Your left becomes 2 at this point, and your subset looks like this, CA. And then you again you go to the right index, you look at B. B doesn't exist. You add B back in. Your max is still 3 because looking at the size of the set, and your right is incremented to 5. And then, which is the fifth index? 0, 1, 2, 3, 4, 5. And then you look at C here, and then you see that C already exists. You will remove C, you will increment. And the reason why we are removing C is because we're looking at the left index, which is 2, which is C here. So you remove C and you increment that left value to 3. And then you come here. Again, you're looking at the rightmost index now. You're looking at 5. Fifth index, you see that it's C, and you add C back into the loop, which means like to the set. And then right is incremented to 6. And you don't do anything with left. But the max still remains the same to 3. And the same thing is repeated for B and B. The reason why we are using left and right indices is because we are trying to remove the leftmost index values to make space so that we can look at other substrings which might have those characters and which could possibly form a longer substring. So that's the reason we start with the left, and we don't clear just like random characters, because they have to be characters that are repeating, that have to be next to each other. They have to be a part of a substring. So if you follow this methodology for any of the examples, it will work. Let's jump into the code for this. So what are the things that we need? So we need a hash set. Let's initialize that. Hash set character set is new hash set. And then you have 3 integer values, int left to be 0, int right to be 0, max is 0. We know that we have to return max in the end, and then what we'll do is we'll just have a while loop. While right is less than s.length, and then we have 2 two conditions, right? So we check if set that contains s dot character at right. So let's actually look at the good case first, where it doesn't exist in the set, and we can actually increment the value of s. So we'll add the value to the set, s dot add right dot character at right, and we need to increment the value of right. So we'll increment it here, and then we'll check the size, and we'll update the value of max if needed. So mat.max of max, and we'll look at the size of the set, since set contains all of the unique characters that we've seen so far. Awesome. If this doesn't happen, we need to remove the characters from the left. So how do we do that? We just do a set.remove s.character add left, and we increment the value of left. Awesome. So let's compile this and see if it's okay. The first test case is okay. Everything else is okay as well. Awesome. So that's the solution for problem 3. If you have any questions, please let me